Hello and welcome to yet another riveting section in Algebra 2. And this is Unit 6, and this is a section about radical functions. Okay, so the first thing we need to do is talk about what's called a rational exponent. Okay, and rational, remember, that means a fraction. Okay, so this is a fraction. So exponents that are fractions. So this is going to be really fun. I really enjoy this. Okay, so we're going to simplify or evaluate numeric expressions using properties of rational exponents, and then we're going to simplify algebraic expressions using properties of rational exponents. So what we know, the first thing is exponents as fractions. We call those rational exponents. Okay, and what we have is raising a base to a power of 1 over n is equivalent to taking the nth real root. So if you had a to the 1 over n, that's equal to the nth root of a, where n is a positive integer. Okay, so now, let's think of an example. Okay, if you took, say, and let's just think of the basics here. If you have, like, say, 3 squared, that's 3 times 3, which gives you 9. Okay, and that's using your exponent. Okay, if we go backwards and we take the root, then we take the square root of 9, okay, really what we're doing there is we are taking 9 to the 1/2 power, and that's going to give us 3. So in your calculator, if you wanted to take the square root of 9, you just type it in, okay, as the square root of 9. Or you could take 9 to the 1/2 power, and it'll give you the same thing. Okay, let's think of something else. Let's think of, like, say, 2 to the 3rd power. Okay, that's 2 times 2 times 2, which gives you 8. Okay, if you wanted to go backwards, you'd take the cube root of 8, and we know it's going to be 2, but we could do the same thing and write it as 8 to the 1/3 power is equal to 2. Okay, and typically, guys, when I was doing this, I had to do all this stuff in the calculator. I didn't, we had the square root button, but if you had a cube root or a 4th root, you had to raise it to the 1/3 or 1/4 power and all that. Okay, so rational exponents with numerators other than just 1. Okay, so let's say, for example, that, instead of a simple, fraction like a third or a half like we had up here, let's say you've got a different fraction. Okay, something with a numerator that's other than 1 and then a denominator n. Okay, so what you can do is you can write these things out 2 different ways, and these are the formulas that you can use. So if you have a to the m over n power, what you can do is you can split that up into the product of 2 exponents, okay, and raise one exponent to another. All right, and one thing that people do is they'll take the nth root of that and then raise it to that power m. Okay, another way that you can do that is you can take a to the m power and then take the nth root of that, all right? So what I want to do is go over an example here where you have, 27 to the 2/3 power, okay? When the number in your rational exponent, if that numerator is other than a 1, okay, you have to follow those same rules. So let's do this two ways, okay? So 2 ways that we'll evaluate it. The first way is we're going to take 27 to the 2/3 power, and we're going to rewrite that as 27 to the 1/3 power, and then we're going to square that, okay? And all I've done is rewrite this and said that, okay, if I take 2/3, I can split that up into the product of 2 times a third, all right, which then I could rewrite as, a power raised to another power. So if I take the cube root of 27, okay, and really, let's number of ways to kind of think about this, but I'm taking 27, taking the cube root of 27, and then I'm squaring it, okay? In 3 numbers that multiply to 27, if you take the cube root of 27, that's just going to give you 3. So this simplifies down to 3, and then you square it, and then it's going to give you 9, okay? So that's one way of doing this, okay? Now let's think of the other way, all right? So the other way, the second way, let's do 27 to the 2/3, and let's rewrite that again, and let's rewrite it the other way, okay? So here we raised 27 to the 1/3 power, let's write this as 27 squared and then raise that to the 1/3 power. Okay, so 27 squared is going to be a total of 729. Okay, and then we're taking that and we're raising that to the 1/3 power. Okay, really what we're doing is we're taking the cube root of 729. Okay, and that's going to give us a value of 9. Okay, so 9 times 9 times 9 times, 9 times 9 times 9 is going to give you 729. Okay, and that's the idea. So you could do it either way. All right, you can either take the cube root first and then square it, or you can square it and then take the cube root. And you know what you need to see about that is that you get the same thing in the end. Okay, I typically like to take the cube root or take the root first, so my number is smaller, and then I can evaluate it. Because taking the cube root of a big number like this, for me, is difficult, especially if there's no technology. So there's that. All right, let's take a look at a couple of other questions here. And let's just rewrite this back in exponential form. Okay, now what I have here is I have 81, the fourth root of 81. So I'm going to take 81, okay, and I'm going to rewrite that as taking that to the 1/4 power. And then I'm raising all of that to the 5th power, all right? And then what I know is that when I have a power raised to a power, I can multiply these two. And so I end up getting 81 raised to the 1/4 times 5/1 power, okay? And so if I multiply those across, I'm just going to get 81 to the 5/4 power, and that's it, okay? And I just rewrote that in exponential form, all right? Here, we want to simplify that, okay? So let's, we have that same problem, and we could do this two different ways, all right? I'll do it both ways. The first way that I'll do it, I'm going to do 81 to the 5/4. Okay, let me rewrite that as 81 to the 1/4 power. Okay, and then I'm going to raise it to the 5th power. Okay, so then I'm going to do, that's the 4th root of 81, and then we raise it to the 5th power. So the 4th root of 81 is going to be, it's going to give me a value of 3. Okay, raise that to the 5th power, okay, and that's going to give me 3 times 3 times 3 times 3 times 3, which is going to give me 243, okay? So the other way is going to be a little, depending on your use of technology, the other way of doing this, if you have 81 to the 5/4 power, then really all you're going to do is rewrite this as 81 to the 5th power, and then take the 4th root, okay? So here's what you've got. If you take 81, all right, and multiply it by itself 5 times, then you're going to get, this is a huge number, 3, 4, 8, 6, 7, 8, 4, 4, 0, 1. All right, so that's going to give us 3,486,784,401. Okay, and then we still need to take the 4th root of this. Okay, and so I would take that number and I'd raise it to the 1/4 power. Okay, and then it's just going to give you 243. Okay, so it'll do the same thing, and you're going to have to use technology here and write those out. But, the first step is your ability to rewrite these. Okay? All right, let's take a look at something here. Okay, and this is a compound interest. So if you're going to see a question like this, you're going to have to make sure you have your notes and refer back to this. But this is compound interest. So interest compounded annually. All right, and so we can talk further about what compound interest means. Basically, this is a bank account that earns money. Okay, so this is a bank account. Okay, that earns money. Okay, kind of a weird concept. Okay, If you have more interest in that, you should, talk to someone involved in banking, maybe your parents, about what all that stuff kind of means. So you have this formula, okay, where A equals P times the quantity 1 plus R to the T power, okay? And so, your P is your principal amount. So that's the initial amount that's borrowed or invested, okay? R is your annual interest rate. That's how fast you earn money, okay? Time is the number of years that this happens, okay? And T is your exponent. And then A is the value that you have after time, okay? So what you have here is you have this problem here where it says calculate the value of a $2,000 investment that pays 5% interest compounded annually after a period of 2.5 years. Okay, so let's say today I go into the bank and I put $2,000 into a bank account, and I'm going to watch it grow for a period of 2.5 years, okay? So, let's list out what we have, okay? Our principal amount is $2,000, okay? Our annual interest rate is 5%, but that 5% as a number is really going to be 0.05, okay? T is 2.5 years, okay? And then A, we don't know. We're trying to find what A is. We're trying to find the amount after T years, okay? So what I have is, let's put all this together, okay? I don't know what A is, but I know that my P, this value here, is $2,000. So I put $2,000 here times 1 plus 0.05, which is R. Okay, there's R. My R was 0.05. And then we're going to raise that to the T power, and that power is to the 2.5 power. Okay, so now what I want to do is I want to evaluate this. Okay, and I'm going to add those two numbers together, and so my amount, my value after a few years, I'm going to take 2,000 times 1.05 and raise that to the 2.5 power. Now that's something that you can just directly plug into your calculator, and we're going to evaluate it. And that's going to give us a value of $2,259.45. Okay? So what you have earned, when you think about this, you have earned $259.45 over a 2.5-year period. Okay? And that's pretty significant, okay? If you just put that amount of money into a bank account and you're going to make $260 pretty much, that's pretty good. Now, unfortunately, in our current state of the economy, we do not have 5% interest rates anymore, okay? Like the one that I have on my savings account is like 0.1%, okay? So I make like 4 cents a month on mine. And I've got like $1,000 in there. It's nothing major, but I just keep, if I get any extra money and it's just kind of coming out, just extra over time. I've had this account open since July. Any extra money that comes in, I put into that little bank account. Okay, sometimes if I get I'll take some money out of my paycheck and put it in there, but it just kind of depends on my finances. So, an applicable thing that is used quite often. This is used very often in banks and such as. So, you're kind of sitting there going, hey, where am I going to use this in the real world? You use it in personal finance. Okay, so before we move on and start talking about simplifying these algebraic expressions, we need to talk about the properties of rational exponents. And so we have 6 different things that we can do, 6 different operations, okay? And I'm going to start over here and work my way down and then over. And so the first one we have is a negative exponent, okay, where you have some number a raised to a negative number, okay? And to simplify this, what we would do is we put this number over 1, okay? Any number is always being divided by 1. So in order to make this value become positive, we have to take it and put it into our denominator, okay? And that then gives us a positive exponent, okay? Now, the other thing that you could do here is, let's say you have 1 over a to the negative n, okay, if your negative number is in your denominator, then you simply just move it up front, or move it up top, and then you just get a to the n, okay, over 1. So works both ways. So you can move it, from the numerator to the denominator and vice versa. Okay, if you have a product of powers, and this means that if you've got some number a raised to a power and then multiplying that by another a raised to a different power, then you're going to add your exponents, okay? So when this happens, you're going to add your exponents, all right? When you have a power of a product, if you take two numbers and you're multiplying them and you raise that to a power, then you take each individual one and raise them to that same power, okay? But that's only if you're multiplying, okay? All right, now up here, if you have a power of a power, which means that you've got some number raised to a power and that's all raised to another power, then you multiply, okay? You multiply your exponents, okay? When you have quotient of a powers, okay, if you have two numbers both raised to an exponent and you're dividing them, okay, then you are going to subtract, all right? And then if you have a power of a quotient, then, say a fraction raised to a power, then you take the numerator raised to that power and then your denominator also raised to that power, okay? So we're going to use these properties when we're simplifying these algebraic expressions. So I've got these three problems here on this page, and I'm going to just, kind of walk you through how I do these and how I, use all of these properties and operations to be able to simplify this, okay? So let's just jump into the first one. Which expressions are equivalent to 10 over 10 to the 3/4? Okay, so I'm going to rewrite that over here. And I'm going to write that 10 over 10 to the 3/4 power. Now, when you just have a single 10, there is an exponent, but that exponent is 1. Okay, so that's an important thing to realize that anytime you have you're always like, well, what are these exponents? Then if there is no exponent, then the exponent is 1. Okay, so now I have a quotient. Okay, I have 10 raised to the first divided by 10 to the 3/4. So when I'm dividing two numbers, both raised to an exponent, then I'm going to subtract them. Okay, and the next step would be 10 to the 1 minus 3/4 power, okay? And when you do that, you're just going to get 10 to the 1/4 power, okay? But, if you wanted to, let's just think about, 1 minus 3/4. This is 1 over 1. Get a common denominator of 4, so multiply top and bottom by 4. So you've got 4/4 minus 3/4, which gives you 1/4, okay? And that becomes your new exponent, all right? So now, this is your answer, okay? Now, you could also, since it is 10 to the 1/4, that's the same thing as writing the 4th root of 10, okay? And you can do that. So there's that, all right. What I'm going to do, okay, let's take a look at this next one over here. Let's make an equivalent expression to this, okay? So I'm going to rewrite this over here. So I've got 5 to the 1/8 power times 5 to the 3/8 power, and that whole thing is being raised to the 3rd power, okay? So there's a couple of different ways to do this. You can multiply this 3 in first and then add your exponents, or you could add your exponents and then multiply that number by 3. Okay, so I'm going to do this two ways, all right? So let's do this method 1, okay? And let's do 5. Let's combine our exponents first here and then multiply them by 3. So if I've got 5 to the 1/8 times 5 to the 3/8, that means I'm going to add these exponents. So I would get 5 to the what would that be? 4/8 power? Or let's write that out like this. Let's write that out as 1/8 plus 3/8. Okay, and then that's going to give me 1/8 plus 3/8 is going to be 4/8. So then I just get, and this whole thing is raised to the 3rd. You need to keep that in there. Okay, that's raised to the 3rd. And then, you can simplify this fraction first, okay? And 4/8 is just a half, so I'm going to do 5 to the 1/2, that whole thing cubed. And then I'm going to multiply 3 times a half. So my next step would be 5 raised to the 1/2 times 3 power. Okay, and I'm going to put that 3 over a 1 so I can multiply those fractions. And then I'm going to get 5 to the 3 times 1 is going to give me 3. Okay, and then 2 times 1 here is just going to give me 2. All right, and that doesn't look very good. So let's kind of scratch that out, and this should be 5 to the, got to write it small, 3/2 power. Okay, now I could also turn this into a rational, or a radical, and I could write this as the square root of 5 cubed, okay? And that's one way. Or I could write it as the square root of 5, the whole quantity, cubed, okay? But that's probably how you're going to have to put your answer. Okay, let's do it another way. Let's do it using the second method. And let's multiply the 3 in first and then simplify our fraction. Okay, so let's do method 2. All right, and so if I do method 2, I'm gonna distribute this 3 and multiply it by each of those. So I'm gonna get this. I'm gonna do 5 to the 1/8 times 3 over 1 power times 5 to the 3/8 times 3 over 1 power. Okay, this is another way to do it. So multiply your numerators, multiply your denominators, and so as a result, I'm going to get 5 to the 3/8 power, okay, times 5 to the 9/8 power, all right? And so now what I want to do is just add my exponents, okay? So now I've got 5 to the 3/8 plus 9/8 power, okay, and then I'm going to get 5 to the 12/8 power, okay, and we can simplify that fraction by dividing each of these by 4, and so we end up getting 5 to the 3/2 power, okay, which is the same thing that I got here, okay, so it doesn't matter how you do it, it just matters that you do it, all right? So that's the idea. There's that. Let's go ahead and simplify this one. Now, each of these ones just had numbers. Okay, so we're going to kind of extend this idea over here to the ones that don't have numbers, the ones that just have variables. So what I'm going to do here on this one I kind of have to do in a specific way. The reason is because the 4, the x, and the y are all different numbers, okay? I can't combine any of these because they don't have the same base. We just have to leave them as they are. So, but this whole thing is being raised to the 3/2 power. So what I'm going to do is I'm going to go ahead and distribute that 3/2 in as my first step. So let me come in here and let's go, let's do 4 to the 3/2 times x to the -4 times 3/2 power times y to the 6th times the 3/2 power, okay? So what I've done is I've just raised that to another exponent, and when you raise to an exponent, you have to multiply your exponents, okay? So 4/3, we can do that a couple different ways. Let's do this here real quick. Let me put this over a 1, okay, and let me put this one over a 1 as well. 4 to the 3/2 power can be rewritten as and I'm going to do this. I typically do the square root of 4, that whole thing cubed, okay? And then I'm going to do, okay, I've got -4 times 3. That's going to give me x to the -12/2 power. And then times y, I've got 6 times 3, which is 18 over 2. So the 18 over 2 power. And then, okay, now let's do this. Let's take the square root of 4. Now if I take the square root of 4, that's going to give me 2. And then I'm taking that number and I'm cubing it. Okay, and then I'm multiplying this. Let's simplify this fraction up here. And let's do -12 over 2. So that's going to be x to the -6 power. And then multiply that by y to the 18 over 2. 18 over 2 simplifies to 9. So y to the 9. Okay, now I can evaluate all these. Okay, I'm going to do a little bit of, let me first do this. Let me put this whole thing over 1. Okay, and I'm doing that because of this x to the negative 6 power. I need to move that down into my denominator, all right? Now, in my next step, let me draw this, okay? Let me just do that step first. I'm going to put that x to the 6 down there, all right, make it positive. If I evaluate 2 to the third, 2 times 2 times 2 is going to give me 8, okay? And then I'm going to multiply that by y to the 9th, okay? And that's my answer, and that's my simplified version of what this is, okay? And so it's pretty cool stuff. It's kind of fun. I really enjoy these once you understand them. So, just practice and, we'll get there. You guys doing a great job, and we'll see you soon. Thanks. Bye.